let's have a look at some two-sided counters. There's so many activities one can do with the two-sided counters, and here we shall show you 2 or 3. This is a puzzle that many of you have seen before. Normally one sees them in stores, and the task is to reverse the order. So we can see that we can put these 3 and it's pointing like in that direction. So the trick is, what's the minimum number of moves to switch the orientation. So in this case, I can move this, so we can see now it's pointing in the opposite direction. So this arrangement, I can change the orientation in 1 move. Now let's see, that's 3 discs. Now we have 6. So the challenge is, what's the fewest number of moves I need to change the orientation? So let's see, we have 6, so I guess I can move that like that. That's 1 move and 2 moves. So I can see with 3 it took me 1 move, with 6 it took me 2 moves. So the challenge now, what's the fewest number of moves needed to change the orientation of, let's see, 4, 5, 6, 7, 8, 9, 10. We need that for you to investigate and see what's the fewest number of moves needed and how do you know when you have them all. Another challenge that's normally given is to look at triangular or triangle numbers. So here they are, we have 3, we have 6, and now if I put this arrangement, I have 10. And a nice task is to look at the sum of consecutive triangle numbers. So let's see what happens if I add 3 plus 6 or 6 plus 10. Now what's nice with this task is, let's see, here we have 6 and we have 3. So I guess if I change that orientation, I can show you visually the 3 plus the 6, and I get a perfect square. So let's see if we can continue with that. So now let's see, we have 6 here, we have 4, 5, 6, 7, 8, 9, 10. So let's see if the similar thing will happen. So if I were to ask you to add 6 plus 10, we know it's 16, but a nice way to show it is if I take this arrangement and just change the orientation. It's a bit messy here, but you can see now what I shall do, so you can see visually what's happening. So the students can see that the sum of consecutive triangular numbers will give you a perfect square or square number. So it's a nice way to demonstrate that fact. Another thing that teachers do with the double counters is to illustrate integers. So let's say for this investigation, we shall make the red positive and the yellow negative. So let's look at some of the concepts that some students have, or problems that they have with integers. So let's add positive plus positive. So let's add positive 2 plus positive 3. Well, that's not too difficult. Positive 2 if the red is positive, so that's positive 2 plus positive 3. You can see visually the answer is positive 5. So let's try the negative. So let's say we have a negative 4 plus a negative, let's say, 5. We can select any number, but let's say it's 5. So that's positive. Let's make the red positive. And let's make that negative. Sorry, let's make negative. I'm sorry. So let's make it negative 4 plus negative 5. So negative 4 plus negative 5 I can just combine, and I can see that negative 4 plus negative 5 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's fairly straightforward. The problem arises when I add a positive plus a negative. So let's see what happens. Let's say that this is our positive, and that's a negative. So if I put a positive plus a negative, you can see what happens. It cancels out, and this is referred to as a zero principle. So here I'm showing you a 0. Here's another way to show you 0. So zero principle, the positive cancels out the negatives. And we can keep on expanding that forever. So that is still illustrating just 0. Now let's add positive plus negative. So let's say we have positive 2 plus negative 2. So you can see if I add positive 2 plus negative 2, we can see that the answer is 0. Let's try another one. So positive 4 plus negative 2. Well, if the positive and negatives cancel, positive 4 plus negative 2, we can see visually that the answer is positive 2. Also, let's have negative 4 plus, let's pick a number. That's negative 4 plus positive 2. Same thing. Negative 4 plus positive 2. The answer is negative 2. It also can be used to demonstrate subtraction. Now one has to be very careful how one proceeds. So let's see. Let's take an easy case. That's positive 5. So if I have positive 5, remove positive 3. So that's positive 5. I remove positive 3. 1, 2, 3. The answer is positive 2. Let's try one more. So that's positive, say 6. Remove positive 4. 1, 2, 3, 4. The answer is positive 2. Let's try the negative. So we have negative, say, let's see, 1, 2, 3, 4, 5, 6, 7. That's negative 7. Let's remove negative 4. Negative 7, remove negative 4. 1, 2, 3, 4. Answer is negative 3. One more example. That's negative 5. Let's remove negative 2. My answer is negative 3. Now let's look at the one that's very, very interesting to illustrate. We have positive 2. And from that positive 2, we now want to remove negative 3. So we have positive 2. We want to remove negative 3. So how can we do it? Well, that's positive 2. So let's go back and look at the zero principle. So that's positive 2. That is still positive 2. That is still positive 2. I can add as many zeros as I wish. And that is still illustrating positive 2. Now I should remove negative 3. 1, 2, 3. This is 0. So that's my answer, clearly shown, positive 5. Let's just try one more. Positive 1. And from that positive 1, I want to remove, say, negative 4. That's positive 1, want to remove negative 4. So that's still positive 1, positive 1, positive 1, still positive 1, still positive 1, and I can keep on going. So that's positive 1. Now I want to remove negative 4. 1, 2, 3, 4. That's 0. That's 0. That's my answer. Positive 1, positive 2, positive 3, positive 4, positive 5. Beautifully demonstrated. So with the double-sided counters, I can show integers quite nicely. One more task we'd like to illustrate. We can also use it for puzzles. So in this particular puzzle, what we want to do is to exchange the arrangement. So the yellow disc will be on top and the red disc will be below. And you'd like to do it in the fewest number of moves. So you move one square at a time. So I can move my yellow. I can move my yellow again. And I can put it here. My red, 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 red. And I can move my yellow up, up. Now we are in a jam because we cannot jump over another disc. We can just slide it. So the task is it possible for these two to exchange positions? It is possible, but what the fewest number of moves needed?